So we have got very interesting questions which are under linear motion and projectile motion. So basically these are the most interesting questions I've come across so far under linear motion and projectile motion, especially question 1 and question part A and part B. Part C is a bit tricky, it's also interesting actually, so we'll see how we are going to solve them. So part A is saying a car undergoes a constant acceleration of 6 meters per second squared starting from rest. Calculate the distance traveled in the third second of its journey. Perfect. Now, how do you understand this question? It is asking us to calculate the distance traveled in the third second. Third second, it doesn't really mean to say the time is 3 seconds. No. So now, let's have our graph. I'm going to give you just a clear picture so that you should understand this. So let's say this is 1. Okay. Or I'll start from this is 0. Then I've got 1. I've got 2. I've got 3. I've got 4. I'll end there. So this is now time. This is the velocity time graph. Let's say this is velocity in meters per second. This is time in seconds. So we want to see which one is going to be our third second. It's not saying that calculate the distance traveled when t was equal to 3 seconds. It's totally different when we say when t is equal to 3 seconds and in the third second. Okay? In the third second is totally different. Okay? Now let me explain from here. What does it mean when we say in the third second? So, when this object or when this car is moving from 0 all the way to 1, this is what we are going to call the first second. Okay? Now when it is moving from 1 to 2, that is in the second second. Then from 2 to 3, that is the third second. Okay? That is the third second. Then from 3 to 4, that is the fourth second. Now, the question is asking us to find the distance traveled in the third second. What does it mean? So we need to find the time, we need to find the distance traveled at t is equal to 2 and at t is equal to 3. At t is equal to 2 meaning we have calculated the distance from 0 all the way to 2. Then when we're finding the distance when t was equal to 3, meaning we're finding from 0 all the way to 3. So if I do t3 minus t2, it's going to give me the distance traveled in the third second. That's why I said this is the most interesting question under linear motion. Okay? So in short, when you have come across this question which is asking me to find the third second, the distance traveled in the third second, you just use from the data we have here, we can clearly see, guys, that we have got the acceleration to be 6 meters per second squared. What else? The velocity initial, it started from rest, is 0. We are not interested in the final velocity, but we want to find the distance, which we don't know. So we have got the first time, which I'm going to call t2, which is 2 seconds. Again, t3, which is 3 seconds. Okay? Now, using this data, I can clearly see that the only formula which can work, which doesn't have the final velocity, is the second one. Because the second one, we are saying d is equal to v initial times t plus half a t squared. So I want to find the distance now. So I'll start with the one for when t was equal to 2. So this is going to be cancelled because initial velocity is 0. So it will be half. Acceleration is 6. The time now is 2. Now I square it. So my d will be equal to 1 over 2 is 0.5 times 6 times 2 squared. It's giving me 12. So 12 meters is the distance it traveled when t was equal to 2 seconds. Not in the second seconds, no. But when t was equal to 2. Meaning from 0 all the way to 2. Okay, I'll leave it there. So I need to find again the distance when t was equal to 3. So I'll say the same formula. I can clearly see that my d will be equal to, this will be cancelled. I'll have half. Acceleration is 6. T is what? Time is 3. Now I have to square it. So my distance will be equal to, I'll say 1 divided by 2 is 0.5. 0.5 times 6 times 3 squared. Okay, let me do it. I'm saying is 6, then times, let me start with 0.5, 0.5 times 6, then times 3 squared. So this is giving me a 27 meters. So this is the distance traveled when t was equal to 3. Now we are trying to find the third second only, this part. I'm supposed to say this 27 minus 12. That was going to be the distance traveled in the third second. Okay? So as simple as that. So we're going to say 27 minus 12. The answer I get, that is the distance traveled in the third second, which is 15. So 15 meters is the distance traveled in the third second. Okay? Sometimes, if you want, you can just do it direct. You can just do it direct, whereby you say the distance traveled in the third second is going to be given by the v initial times t plus half, then acceleration, then t when it was equal to 2 squared. Then you do, when it was equal to 3, now you square it. Then you put them in brackets, minus v initial times t. You put also in the brackets, plus half a when t was equal to 2, now squared, like that. If you plug in the values direct, you end up having 15. So any type of equation which is going to ask you to find the distance traveled in the third second, this is the simple formula you have to follow. If you have been given the initial velocity, you plug in the initial velocity there. But in this case, they said it is started from rest, meaning the initial velocity is 0. Okay, so that is it for part A. Now let's go to part B. Now part B is also interesting, such that it needs us to think. Okay, so the question reads: a projectile's launch speed is 5 times its speed at the maximum height along its trajectory. Calculate the launch angle of the projectile. That's why I'm saying this is the most interesting question under projectile motion, actually. So here is my projectile motion. We are launching it from this point, okay, going there until it reaches there. They are saying that the initial speed which we are going to have is 5 times its speed at maximum height. At maximum height, we expect to have the final velocity there. Okay, so meaning here I'm going to have 5 final. What does it mean? Meaning this initial is the same as 5v final. It is the same. At this point, the velocity at maximum and the initial is going to be the same, because we have been told that a projectile's launch speed is 5 times its speed at maximum height along its trajectory. Okay, so the angle is here, the one we are looking for. As simple as that. So now we are going to use, when we are trying to resolve this into components, we know that we are going to say v initial, which is v initial in x direction, it is given by v cos theta. Okay, v initial cos theta. Now here let me also use I as initial. Okay, what else are we supposed to know? Since we are saying that this is the same as the final velocity, meaning at the same time I can also say that the final velocity is going to be the same as v initial times cos theta, because they are the same. Okay, so if they are the same, we are saying that v initial is equal to 5 v final, meaning that at this point here where there is initial here, I can replace it with 5. What do I mean? What I mean there is that I can say v, I, I can even start with this one here. We are saying that v final, v initial in x direction, okay, or just v initial in this case, is equal to v initial times cos theta. But it is the same as the velocity with the final, meaning what I mean there is that it is the same as the final velocity. Now we have equated this equal to v initial equal to that, but at that point they are the same, so I can replace this with the 5v initial. So this is going to be replaced by 5v initial, because they're the same at that point. So what I'm going to do now, I'm going to divide both sides by 5v initial, even here 5v initial. These two guys will cancel out. Okay, so I'll remain with cos theta to be equal to v initial divided by 5v initial. So v initial and v initial can go. I'll remain with cos theta to be equal to 1 over 5. I want to find the angle. What are we going to do? So I'm going to say, cos, I can get the inverse, where I'm going to say the theta will be equal to the cos inverse 1 over 5. So theta will be equal to, it's going to be shift then cos, open brackets, 1 divided by 5. I close the brackets. I'm getting 78.46, so I can round it off and say 45. 78.5 degrees. That is the angle at that point. So if I use this angle, I'll be able to get, these things are going to be the same at that point. Now the most interesting part about this question is this. What we need to know is here, in a case where you have not understood, let me just repeat it. I'm saying the v initial is equal to 5 times the v final. At this point they are going to be the same. That's what we mean. Okay, now we also know that this v initial in x direction is going to be v initial cos theta. Okay, this velocity and that velocity is going to be the same at that point. So what are we going to do? We are going to say, since these are the same, we can replace it v initial. Okay, the v initial, this v initial is going to be equal to, I can replace this with that because they are the same. So 5v final cos theta. The velocity is the same at this point. Okay, we don't have to struggle. That's the reason why I just replaced this v final with, I said it's v final times initial cos theta. Then I divide this side by v, even here 5v initial. These they will cancel. So I'll have cos theta is equal to v initial divided by 5v initial. These again they will cancel. I will remain with cos theta to be equal to 1 over 5. Then you say theta will be equal to cos inverse 1 over 5. You end up having 78.46. If I round it off, it will be 78.5 degrees. As simple as that. Now we have another projectile motion question, which is very, very important. So here is our question. A rock is ejected from a volcano with a speed of 25 meters per second at an angle of 35 degrees above the horizontal direction as shown below. So we can see the diagram there. Calculate the time of flight of the rock. Use G as 9.8. So we can solve this question in two ways. I'll start with the simplest one. I can use, I know that from our data here we can see that we have been given the velocity to be 25 meters per second. We have been given the final, not really, the final we have not been given. We have been given the distance to be negative 20. What else? The G to be 9.8. The most important thing here is I'm going to start with this one. If I use D, since I don't have time, I want to find time, I can use the second equation. V initial. Now this V initial is in which direction? The y direction. Okay? Times T plus half gt squared. Now, according to SOHCAHTOA, we know that Vy will be equal to V sine theta. So I'm going to replace this with V sine theta times T plus half gt squared. But what we should remember here is it is going up. We are now taking it's going in that direction. Therefore, it is going away from the gravity. Okay, since it's going up. G in that case is going to be what? It's going to be negative. Okay, so what I'm going to do now is I'm going to say D, we have been told that is negative 20. I will just put there negative 20. Our V is 25, then V, or is 25, then sine. The angle we have been told is 35. T we don't know. Plus half. Here is negative 9.8. T is the one we don't know. So I have negative 20 is equal to, if I do 25 sine 35, okay, 25 sine 35, it's giving me 14.3394. So I can just say 34. Because of this minus, meaning here I'll have minus. These two, 9.8 divided by 2 is 4.9 t squared. What I can do now is I can shift this to the left hand side so that here I minus 0. 14.34, this I need to put t minus 4.98 plus 20. Now this is a quadratic equation. Here is supposed to be squared. I can now get rid of this part. So this is my quadratic equation. I'll just put it here. I can rearrange it and say it is negative 4.9 t squared plus 14.34 t plus 20 is equal to 0. Meaning this is my A, this is my B, this is my C. So using our quadratic equation, we know that t will be equal to plus or minus, that's not the quadratic formula, it's negative b plus or minus the root of b squared minus 4ac, everything divided by 2 times a. So my t will be equal to, my b in this case is 14, so it will be negative 14.34 plus or minus the square root of, my b is 14.34 squared minus 4, my a is 4.9, then my c is 20. I'll divide this by 2 times my A is negative 4.9. So T will be equal to negative 14.34 plus or minus, in the brackets there, what we're going to have, 14.34 squared is giving me, so I'll say the root of 205.635, so I'll just say 0.64. Negative and negative will give me positive, so I'll say 20 times 4 times 4.9. 20 times 4 times 4.9. So I'm getting 392. Everything has to be divided by, if I do this one, I'll get negative 9.8. So I'll get rid of this. Now, inside the square root there, negative 14.34 plus or minus the root of, if I want I can just do it directly. I'll just do plus, then I just find the answer directly. So I'll say 205.64 plus 392. I'm getting 5,000 or 597.64. Now the square root of this number is giving me 24.4466. I just said 24.45. Okay, then I divide this by negative 9.8. So now I can get rid of this. So here I'll also be doing, I'll say T will be equal to, is going to be negative 14.34 plus 24.45 divided by negative 9.8, or T will be equal to negative 14.34 minus 24.45. You divide it by negative 9.8. Let's see. My T for the first part is going to be negative 14.34, negative 14.34 plus 24.45. So I'm getting 10.11 divided by negative 9.8. So this is giving me negative 1.03 seconds. Let's go there. Negative 14.34 minus 24.45 divided by negative 9.8. So this, let me redo it, negative 14.34 minus 24.45. So it's giving me negative 38.79. Now this divided by negative 9.8. So I'm getting my T to be equal to 3.958 seconds. So in this case, since we know that time can never be negative, this is not the answer. Our answer in this case is 3.958 seconds. So this is the first method which you can use to find the time actually. But there is another method which I'm going to show you, which you can use to find time. So let's just put our time here. We see if we're going to have the same time. So we are saying T will be equal to 3.958 seconds. Let's get rid of this. Another approach, I can get it in a way that this is more like the third trajectory. Now in the third trajectory, I mentioned to say, if you have been watching my videos, I mentioned to say it is very important for you to know that finding time in the third trajectory, you have first to find the maximum height here. This maximum height, we are going to add it with this one. When we add it, that is going to be our H max. So initially, we need to find the formula which we use to find the time from this point all the way to that point. And that formula is T is equal to V sine theta divided by G. Okay? That is, if you have got this trajectory, then you have got point A and point B and point C. So you are finding the time from point A to B. That is this formula. Now, since this is the third trajectory, let me just redraw a simple diagram for third trajectory. It has started from this point going there. So we know that from this point here we are going to have the maximum height for the first trajectory. But again, there is another height. Now for this one here, let me just put it small h. The capital H is the one we are trying to find. So this we have been given that is 20 already. In this case, I'm going to get it as a positive. Then now I need to find from this point here, it is in free fall, because most of the times it's going to be like this. Let me show it like this. Just comes like that. It is in free fall. So in free fall finding time, we know that d is equal to v initial times t plus half gt squared. In this case, g will be positive because it's going toward the gravity. Okay, then I'm going to say d will be equal to, it has started from rest at this point, so this will be cancelled. We'll have half gt squared. So we do times 2 everywhere. So this h is the same as this h we are talking about here, the whole h. So I'll have 2d, which is that h in that case, is equal to gt squared divided by g divided by g. T squared will be equal to 2d over g. You get the square root. T will be equal to the root of 2d over g. Now when I find this time, I add it to this time. That will be the total time. Now that's how we find the time from the first one I've given you and this one. That's how we find time in the third trajectory. So meaning the total time, to find the total time, this is the formula you have to use. You say the total time will be given by v sine theta divided by g plus the root of 2d divided by, in this case the d we are talking about here is the maximum height from this point all the way to that point, okay, times g. So in short, you can just say the h max. Okay, that's just cool. You can just put there, you say plus the square root of 2h max divided by g. Now we need to find the h max. We know the height from this point, from that point here. Well, let me just put it here. We know the height from that point all the way down, which is 20. But we don't know this height. To find that height now, we'll go back to projectile, where we say the h is given by v sine theta. It is v squared, then this one now squared. Then we divide it by 2g. But in this case, I'll just make it simple, which is this v sine theta. Then I square it direct. Then I divide it by 2g. So that h we are talking about here is going to be, the velocity is 25. Then sine 30, we square sine 35. Okay, we square it, divided by 2 times 9.8. So my h in that case will be 25 sine 35. The answer I get, I square it, divide it by 9.8 times 2 is 19.6. I'm getting 10.5. It's 10.49, but it's just 10.5 meters. Now this h, so to find the h max is going to be the h plus the small h. Now the h is the one I found here, which is 10.5. The small h here is this distance which I've been given. It's negative 20 because it was going from this point here, it's just going down. But in this case, since I want just to get it as positive, I'm going to say plus 20. So I'll end up having my h max to be 30.5. So since I have everything now, I'll go ahead and plug in the values here. Okay, I'll say my t will be equal to v is 25 sine 35 divided by 9.8 plus the square root of 2. The h max is now 30.5 divided by 9.8. So t will be equal to, this part only is going to give us what? 25 sine 35 or sine 35 then divided by 9.8. That part is giving me 1.463 seconds plus that one is 2 times 30.5. Now I divide it by 9.8, then I get the square root. So this is giving me 2.494. If I round it off, it's going to be 495. So let's add now. That would be our time. So 1.463 plus 2.495. So this is giving me exactly 3.958 seconds. So as you can see, this answer and this one, they are the same. So you choose which method is okay for you. Okay? So that is it for this question.